Skyscrapers rising in a matter of days. Dams built by artificial intelligence. Cities that breathe after the rain. This is the first time we have carried out a project like this. A tunnel so large, never before attempted anywhere in the world on this scale. While the West is still drawing blueprints, China is already laying the foundations of tomorrow. It is not waiting for the future. It is assembling it, one colossal and seemingly impossible project at a time. Mini Sky City, the skyscraper that broke time. In 2015, a skyscraper in Changsha, China, rose faster than anyone thought possible. 57 floors, 204 meters tall, built in just 19 days. This wasn't a miracle. It was mathematics. Engineers at Broad Sustainable Building Corporation turned construction into an industrial process. Every module, steel structure, floor slabs, electrical systems was prefabricated off-site under controlled conditions, then transported and assembled like pieces on a production line. The result was Mini Sky City, the first skyscraper to erase the line between architecture and manufacturing. Its lightweight, fire-resistant steel structures fit together with millimetric precision. Each facade panel was designed to reflect sunlight, reducing energy consumption by more than half compared to conventional towers. Inside, intelligent ventilation systems circulated filtered air through every floor, proving that speed didn't have to compromise sustainability. But the project left the world with questions. Could something built so fast last for decades? Could modular skyscrapers redefine cities? Tests continue today, but Mini Sky City remains a symbol of what happens when engineering stops obeying the clock. The Kala Power Plant. In a desert where temperatures soar above 45 degrees Celsius by day and fall below zero at night, engineers built something that shouldn't exist. The Kala Power Plant. Completed in 2019 within Dubai's Desert Conservation Reserve, this hybrid facility redefines what renewable energy can achieve in extreme climates. At its center is a concentrated solar power system capable of generating 50 megawatts of clean electricity. Mirrors track the sun across the desert, reflecting heat onto a central receiver tower. That heat is stored in molten salts, allowing the plant to continue producing energy long after sunset, something conventional solar farms cannot match. Adaptive cooling systems keep performance stable even during sandstorms, while advanced batteries balance demand fluctuations. Every component was designed for resilience, efficiency, and minimal carbon emissions. This is not just a power plant. It is a proof of concept that renewable energy doesn't need perfect conditions. It can thrive in the harshest places on Earth. AICT Park, 3D printed. In 2020, engineers in Ahmedabad, India, unveiled something that looked more like digital art than civil engineering, the world's first fully 3D printed public park. Instead of cranes and concrete mixers, robotic arms extruded layers of concrete guided by complex algorithms. Every curve of benches, pavilions, and sculptures was computer-generated. Every structure was shaped to handle load and tension through geometry rather than volume. Traditional molds disappeared. Design freedom finally met structural logic. Large-scale concrete 3D printing allowed architects to create shapes impossible to build by hand. Material waste fell by almost 40%. Construction time dropped to weeks. Each printed surface carried micro-textures that increased durability and weather resistance. This wasn't just an aesthetic experiment. It marked the moment additive manufacturing left the lab and entered real infrastructure. Shanghai's 3D printed bridge. In 2019, Shanghai engineers achieved what once seemed like science fiction, a 26-meter pedestrian bridge printed entirely in reinforced concrete. 2 robotic arms worked in sync for 450 hours, depositing concrete in interconnected segments with micrometer precision. Each of the 44 main units and 66 railing sections was digitally designed, allowing engineers to simulate load behavior long before printing began. The result? A bridge that supports over 1.5 tons of live weight using 30% less material than a conventionally molded one. Embedded smart sensors monitor vibration, tension, and temperature, feeding data into a system that learns how the bridge breathes. More than a shortcut over water, it's a living demonstration of architecture turning into code. Relocation of the Hawei Shikumen building. In 2018, China faced a challenge that would have reduced most cities to rubble. The century-old Hawei Shikumen complex sat directly above an area slated for massive underground redevelopment, parking tunnels, metro lines, and public infrastructure. Demolishing it would be easy. Preserving it required reinvention. Instead of destroying history, engineers moved it. Using nearly 200 robotic hydraulic jacks, they lifted the entire 8,000-ton structure from its foundations and inched it step by step to a safer location. The process took weeks, each movement monitored by laser alignment systems and structural sensors to prevent cracks. Once the underground construction was complete, the building was gently returned to its original location, fully intact.
The Jianong Gorge Bridge in the Sichuan Mountains, where cliffs plunge thousands of meters into mist, engineers built a bridge that seems to float between worlds. Completed in 2017, it spans one of Asia's deepest gorges, 820 meters long with a 620-meter main span. Designed to withstand violent winds and seismic shocks, its anchored suspension system grips directly into granite rock. Cable cranes had to be suspended across the canyon like mechanical tightrope walkers, since traditional cranes couldn't reach. Suspended over the void, this bridge connects more than just 2 sides of a valley, it connects ambition to reality. Sponge cities. In 2015, China faced a growing urban crisis. Cities were flooding faster than they could expand. The solution didn't come from higher walls or deeper channels, it came from nature. The Sponge City initiative taught concrete how to breathe. Instead of forcing rainwater away, these cities absorb it. Permeable pavements, rain-absorbing parks, and wetlands integrated into neighborhoods store and purify water before returning it to the ground. In Wuhan, Shanghai, and Beijing, floods have decreased, groundwater has risen, and the air is cooler. What began as an environmental experiment became a new philosophy of urban life. Cultural centers of Foshan and Anji. While much of China's progress points upward, 2 projects turned inward toward culture and identity. The Foshan Cultural Center, opened in 2016, draws inspiration from Lingnan traditions, open courtyards, and rhythmic ventilation. The design translates old wisdom into modern sustainability through cross-ventilation and adaptive natural lighting. Further east, the Anji Culture and Art Center, completed in 2019, pushes cultural form even further with a bamboo leaf-shaped parametric roof and a dual facade that adjusts to sunlight throughout the day. Beneath it, a rainwater system circulates through reflective pools and irrigation channels. In modern China, architecture isn't just built, it performs. Phoenix Towers. At the heart of Wuhan, 2 colossal silhouettes were envisioned to rise, not only touching the sky, but powering it. Proposed in 2012, the Phoenix Towers represent ecosystems turned vertical, not part skyscraper, part power plant, part living forest. Clad in solar panels, shaped with internal wind turbines, and designed to host more than 200 species of plants, the towers aim for energy neutrality through sunlight, wind, biomass, and hydrogen cells working in a closed loop. Once completed, they will be vertical cities producing more energy than they consume. Yanggu 3D printed dam. In the mountains of Yunnan, engineers rewrote the rules of hydraulic infrastructure with the Yanggu Dam, the world's first major dam built primarily through additive manufacturing. Completed in 2021, 45 meters tall and 300 meters wide, it was constructed not by human hands, but by code. Using low-carbon geopolymer concrete, robotic printers applied each layer with millimetric precision, while drones scanned the site for geometric accuracy. Construction time fell by 30%, and waste was nearly eliminated. Each machine, trucks, cranes, mixers, operated autonomously, communicating through an AI network that coordinated workflows in real time. Construction became choreography, a synchronized performance of machines building for the planet, not against it. China's advantage isn't luck, it's intention. While others debate the future, China is already building it. From 3D printed dams to self-sustaining towers, these projects prove one thing: progress doesn't wait.
China keeps pushing the limits of what humanity can build, faster, taller, smarter, and on a scale the world has never seen before. And if there's one thing today proved, it's this: the future isn't just coming, it's already rising, floor by floor, right in front of us. If you enjoyed exploring these mind-blowing projects, make sure to hit the like button. It helps this video reach more people. And don't forget to subscribe to the channel so you don't miss the next deep dive into the most impressive engineering feats on the planet. Thanks for watching. And remember, what we call impossible today, China might already be building tomorrow. See you in the next video.